Welcome everyone. In this walkthrough we'll take a look at a method to produce an alkene from an alcohol on a laboratory scale. I'll go over methods that can be used to purify the product and a calculation to work out percentage yield. The final part of the question involves the electrophilic addition mechanism associated with this reaction. All of this content is relevant to A-level chemistry students and BTEC Level 3 applied science students studying Unit 14. This is the format for the walkthrough. It's an AQA A-level chemistry year 2 past paper question. Details are in the description. Let's get started. Here's the first part of the question. Press play when you're ready. The reaction mixture in the pear-shaped flask is heated. This gives particles enough energy to react. Heating the particles also turns the reactants and any products into a gas. A bung with a thermometer must be placed in the neck of the pear-shaped flask. This prevents any gases from escaping into the atmosphere. The thermometer bulb must be at the same height as the condenser. A condenser column cools gaseous molecules, converting them back into a liquid. Rubber tubing is connected from a cold tap to the lower inlet of the condenser. Rubber tubing is also connected to the upper outlet of the condenser and placed in a sink. The alcohol will have a higher boiling point than the alkene due to the presence of hydrogen bonding. The thermometer is used to ensure that the temperature never rises above 83 degrees Celsius in this case. The distillate collected at this temperature will mostly be the alkene product. Here's the next part of the question. Pause the video and press play when you're ready. A separating funnel can be used because the two liquids are immiscible. They do not mix. Liquids tend to be immiscible if they have very different densities or, as in this case, one of them will form hydrogen bonds with water but the other will not. Here's the next part of the question. Press play when you're ready. An organic liquid that contains water as an impurity can appear cloudy. A drying agent can be used to remove the water. Anhydrous calcium chloride is a drying agent. When the anhydrous calcium chloride is added, it is converted to hydrated calcium chloride, removing the water. When the organic liquid is dry, the liquid will be clear or no longer cloudy. Here's the next part of the question. Pause the video, have a go, and press play when you're ready for the answer. From the balanced equation, we can see that this is a 1-to-1 reaction. 1 mole of the alcohol will produce 1 mole of the alkene. We can work out the amount of the alcohol at the start of the reaction by using mass divided by molar mass. We can use the same equation to find out the actual amount of the alkene that is produced. Percentage yield is found by dividing the actual amount of the alkene produced by the maximum amount of alkene that could be produced theoretically. The amount of alcohol used works out to be 0.144 moles. To work out the mass of the alkene, multiply density by volume. The amount of the alkene actually produced works out to be 0.040994 moles. The yield works out to be 28.5% in this case, given to 3 significant figures. Here's the next part of the question. Press play when you're ready to go through the answer. Curly arrows show the movement of a pair of electrons. This is associated with bonds breaking and forming. The mechanism for this reaction is electrophilic addition. As the bromine molecule approaches the double bond, a temporary dipole is induced. This is shown with the delta plus and delta minus symbols. The bromine molecule is behaving as an electrophile, an electron pair acceptor. The blue arrow shows the carbon-carbon double bond breaking, and 2 electrons from this bond go to form a single bond with the bromine atom. The black arrow shows the bromine to bromine bond breaking, with both of the electrons going to the other bromine atom. A carbocation intermediate is formed. There is a positive charge on the carbon atom that is only making 3 bonds. It is a good idea to practice drawing mechanisms using skeletal formulae. These often come up in exams. The bromide ion donates a lone pair of electrons to form a covalent bond with the positive carbon atom. The product is shown here, 1,2-dibromo-cyclohexane. Thanks for watching. Post in the comments if you have any questions or suggestions. Good luck with your studies and take care.